Hello and welcome to the seventh lecture of Introduction to Logic. As I told you in the last lecture that we have divided this part of the lecture, that is where we are doing some exercises with truth tables, into three parts. So we have already taken the first lecture or the first part of this lecture. Now we are taking the other two lectures. Now, as you can see that the questions with truth tables, you will find a lot of questions in the books, and I will be taking them if you have any problems with them in regular classes. Now, I need to discuss few things which I think it is important for all of us to understand, that how truth tables can be used as decision procedures. But before going into the decision procedures, let me again come back to the concept of validity, that how or what is the notion of validity in a truth table. We discussed validity on a lot of fronts. Like we said that validity is a negative definition, right? We said that it is impossible for the premises to be true and conclusion false. So this was the basic definition of validity. Now we also said that if the premises are inconsistent, so an argument will be valid. We also know that if the conclusion is a tautology, then also the argument is valid. So all these things gives us a lot of hiccups, that what is that notion of validity, or how we understand the notion of validity, or how we should understand validity properly. And truth tables gives us a very clear understanding of validity. So I will give you a very basic understanding of validity using truth tables as well. When we were using truth tables, sorry, when we were using truth tables, we discussed that we should not have a bad line. So we have drawn the premises and the conclusion. We checked if there is a good line, if all the lines are good. If there is a bad line, then the argument is invalid. If there is no good line as well as no bad line, then also the argument is valid, and so on. So what is it, or how is it that we can find or check the validity of an argument using truth table? So I will take a very simple argument first, and we have already taken such kind of examples, and I will try to demonstrate that how you understand the notion of validity. But before that, let me define you. Like suppose if P1, P2 up to Pn are premises. Fine. So P1, P2 up to Pn, we have premises. And suppose C is the conclusion of an argument. So usually, and this is the basic definition of validity, if you conjoin, say, P1 and, I'm using the AND function, P2 and whatever, say Pn up to Pn, we have all conjoined them together. We take their conjunction. Then we put an implication and we put the conclusion here. So this value has to be a tautology. If this is the case, then an argument is valid. If it is not the case, then the argument may not be valid. So this understanding, or this is something which we need to create. Now, let us check it with the help of an example and see that how this comes out, right? So I take a very simple argument, an argument which we have taken before as well, right? Like P implies Q, P therefore Q. Now this is the argument. So you know that P implies Q is one premise, P is another premise, and Q is the conclusion. So what I will do, I will take a dot function of this and I will put an implication over here, and I will find the value of this. This is the idea, that if this comes out to be a tautology, then this argument is going to be a valid argument. Now you know what is the truth table of P implies Q. It is true, false, true, true. What is going to be the truth table of P for that matter? True, true, false, false. What is here? True, false, true, false. What is going to be the dot function of these things? The and, the conjunction of this will be true, this will be false, this will be false, this will also be false. Fine. Okay. Now we can forget these two values. So I am taking it off so that you are not confused. I take this value off and take this value off. We need to find the implication of this. How we will find the implication? True implies true is true. False implies false is true. False implies true is true. False implies false is true. So you can see that this is a tautology. That makes this argument valid. Now this is something which you should understand, that an argument is valid if the conjunction of all the premises implying the conclusion is a tautology. So this is another way of defining validity. But you might be bored with this example, P implies Q, P therefore Q, and so on. So let us today take a new example which we have not taken already, and see how we can check the validity of that argument. And maybe we will take an argument which is not in itself connected with each other, right? So let me take an argument like, okay, if we take this argument, P implies Q, this is the first line. Second, Q implies R, fine. Therefore, P implies R. So you know the premises are P implies Q and Q implies R, and the conclusion is P implies R. It also looks like that first law of thermodynamics, right? It is also called hypothetical syllogism. But does not matter. You do not need to know the name or all these things right now. We will be already in the coming lectures, we'll be introducing these things. But let us check the validity of this argument. Now this is a valid argument, if you can take my words for it, but we can always check. Now this is having three units, three simple statements, P, Q, and R. So it will be an 8 table. So I will draw the whole of the truth table for you to also understand it, because beforehand I draw only a part of it, but now I'm drawing the whole of it so that you have a very basic understanding of it. So how many things we have? We have P, we have Q, we have R, we have P implies Q, we have Q implies R, and we have P implies R. These are the things, right? So one way is to draw the whole of the truth table. So let us draw the whole of the truth table first and understand. So as you know that there are 3, so there will be 8 rows. So I will draw it like this: true, 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 false, 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 false. Then true, true, false, false, true, true, false, false. Then this will be true, false, true, false, true, false, true, and false, right? So P implies Q, this and this, sorry, this and this. P implies Q, true, true, false, false, true, 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 true. Q implies R, true, false, true, 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 false, true, true. Fine. P implies R, this and this. So true implies true is true, True implies false is false. True implies true is true. True implies false is false. Then all of them will be true. So this is the truth table which we have drawn. Now, with the help of truth table also, you know that how to check the validity of an argument. So you see that these are your premises. This is one premise. So I put it as premise 1. This is premise 2. And this is going to be your conclusion. Right? So you have this. Now you need to check. So you see that this line here, the premises are true and the conclusion is also true. So it is a good line. Then you find this line where the premises are true and the conclusion is also true. Then there is this line where premises are true and the conclusion is true. And here also the premises are true and the conclusion are true. So this is having 4 good lines, no bad lines. So given that there is no bad line, this argument is valid. Now you can check it with the help of that understanding which I gave a few minutes back in this lecture, that how you can see that whether the premise implies conclusion is a tautology. Now you know that these are the premises. If we put a dot function between these two and we put an implication between these two, so we will see that whether it is a tautology. So I remove this because this is of no use for us now. So I remove this. Okay. Now I make this as P implies Q as one premise, and I put an AND function. Q implies R is the second one, is the second premise, and here I will put an implication for this. So this has to come as a tautology. This is another way of checking. But first let us draw this. So true, true is true, true, false is false, false, true is false, this is also false, this is true, this is false, this is true, and this is true. Fine. Okay, now we will see the implication of this and this. So I will remove these two so that again there is no confusion. So I remove this and I also remove this. So we can now draw the implication. So true implies true, true. False implies false, true. False implies anything, as you know, true. So all these are true. Now true implies true is true. False implies anything is going to be true. True implies true, true. True implies true, true. So you can see this is a tautology. So there are ways to check an argument, and these are certain things which you should understand, that how you need to understand, how you need to study an argument using the truth tables. There can be arguments which are very unrelated by nature. Right now this looks like the first law of thermodynamics, as I said, and we are very well with this understanding, you know, that if P implies Q and Q implies R, so P will be implying R. This understanding is very normal or very basic for our human understanding as well. But let us take an argument where we do not know about the premises and conclusion because they are so damn unrelated to each other, right? And let us use this method to see whether that argument is going to be a valid argument. Because in that argument, you will not find a bad line, you will not find a good line. What kind of argument will be that? Let us take an argument like Q negation Q, therefore P. Suppose if we are given this argument that prove the validity or invalidity of this using truth table, or show or decide whether this argument is a valid argument or not. Now let us draw the truth table. If we draw the truth table and we take Q as the first one, negation Q, and P as the second one, so the truth table will be 2, true, false, 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 true, true, and this will be true, false, true, false. Now as you can see there is no good line, because when both the premises are true, you will not find when the both the premises are true. So you feel very uncomfortable, right? As I told you in the last classes, that if there is no good line and if there is no bad line, then that argument is valid. Precisely because if there is no bad line, then the argument has to be valid. But then again, it is a little bit counterintuitive. We do not feel comfortable with this understanding. There is no good line, there is no bad line, still you are calling that argument valid. So what is it? The understanding is that the premises implies conclusion has to be a tautology. Now let us take the premises together with the conjunction. So we put the conjunction sign here and we equate the values. So this is going to be false, this is also false, this is also false, and this is also false. I will remove these two datas now because it is of no use for us. So I remove them completely. So we have all the premises to be false, or this part q dot negation q is going to be false, because you know that there is a contradiction. Now false, and you know that we will be taking this value. So false implies true is true, false implies false is true, false implies true is true, false implies false is true. In fact, you know that false implies anything is true, right? So irrespective of the fact that here it is P, it could have been anything, Q, R, Z, N, I do not know what, you can put anything. This has come out to be a tautology. So this might have answered your question or your understanding, which a student also asked in my lecture, which was uploaded, that if there is no good line or if there is no bad line, then what is the status of an argument? The status of that argument, the status of any argument which is not having a bad line is going to be valid, right? If there is a bad line, then it is invalid. If there is no bad line, then that argument is if there is no bad line, then that argument is valid. So that understanding has to be clear. So, and this is basically the definition of validity. So what is the definition of validity? Now you have so many definitions of validity. One definition of validity will say that the conjunction of the premises implying the conclusion must be a tautology. Thank you.